Introduction.
The construction sector is a vital component of every economy in the world. Thus, the construction sector is responsible for the development large quantities of waste as well as the release significant amounts of greenhouse gases to the environment. Cement-based building materials such as concrete are widely used for the production of various infrastructures. In recent years, it became well known that the manufacture of cement results in the high emission of greenhouse gases that contributes to the global warming. Estimate that 2 billion tons of greenhouse gases are emitted each year from cement manufacture, which account around 6% of the world anthropogenic greenhouse gases emission. In 2020, carbon dioxide emissions for Malaysia were 262.2 million tons. Over the last 50 years, carbon dioxide emission for Malaysia grew substantially from 14.6 to 262.2 million tons. Since the rise of urbanization in recent years, cement production gives negative impact to the environment.
Here is the basic concept of geopolymer concrete. Geopolymer concrete is a type of concrete that is made by reacting or dissolving aluminate and silicate material with an alkaline activating solution, which are sodium silicate and sodium hydroxide, and subsequently polymerize into molecular chain and become a binder. It uses precursor or aluminosilicate source material either from natural or industrial byproduct such as fly ash,
The
granular
constant
ground
rise in
slag,
demand of concrete
metakaolin,
has
and
resulted
silica
in
fume
increase
for
to the production and
polymerization
use of
process.
cement.
The first
Hence,
phase
it
of
is imperative
alumina
that
is to create fast
environmental-friendly
heating time,
alternatives to
while
cement
second
be
phase of
utilized in
silica is
construction
to create
to ensure
strength.
the long-term viability of environment
Geopolymer
sustainability.
concrete is
It
curing
is
in an
possible to use
oven at
variety of
below
waste
ambient
products
temperature,
generated
unlike
as
OPC, which curing
replacement to
in
the
water.
standard resource
Geopolymer
used in
concrete can
cement
be called
production.
as eco-cement, as eco stands for economic element due to the no cement involved for the production, as well as no hydration process as there is no water addition on it. The advantages of geopolymer concrete are it has high compressive strength, which have been found out up to 60 to 70 megapascal after 28 days. The concrete gains its compressive strength rapidly and faster than ordinary Portland cement. It has
The
greater
sustainable
corrosion
replacement for
resistance, but
cement
for
can
some
result in
cases
reduction
where
of
geopolymer
greenhouse
concrete
gas
is
emission,
combined with
the
reinforced
cost and the
concrete,
use of raw
it will create
material.
high potential of corrosion and
The
element
alternative
corrosion
that can
harm
be used
from
as a total
inactivators, which
replacement
is
of
sodium
cement
or
in
salt.
concrete
It
are
has high
alkali
tensile
activated
strength
material
and
which
lower
result in
shrinkage,
geopolymer
as well
concrete.
as can reduce greenhouse emission as much as 19% compared to OPC. The disadvantages of geopolymer concrete are it is not easy to handle sodium hydroxide as it is very reactive and need proper guide from skilled worker to perform mixing process. Normally, it has been used as precursor. And lastly, the uncontrolled amount of dosage will cause corrosion to the steel bar or no polymerization process involved.
What is the properties of fly ash geopolymer concrete? The first property is workability. The inclusion of fly ash in the blend develops the slump rate. The greatest slump rate was reported when using fly ash. The workability of geopolymer concrete is reduced with higher concentrations of sodium hydroxide solution. High workability was carried out because of the spherical grains and glassy surface of fly ash, which is finer than cement and rise higher workability of geopolymer concrete. The second property is setting time. The results indicates that the fresh geopolymer concrete had a lower setting time of 28 to 58 minutes due to the presence of high calcium content of fly ash. The setting time is lower because the geopolymer concrete with fly ash harden faster than other cement. The third property is compressive strength. When fly ash is used as a binder, the compressive strength is increased with a higher molar concentration of sodium hydroxide. The activation of the reaction of the internal silica and alumina components caused by the increased breakage of the glassy chain of fly ash, which is itself provoked by the high alkalinity resulting from the increase of the molarity of sodium hydroxide. The use of fly ash as a precursor can enhance the compressive strength of the geopolymer concrete.
Design procedure of fly ash geopolymer concrete. Fly ash were activated by using 3 different dosages of sodium hydroxide solution. The specimen were constructed using a Hobart mixer by the drying mixing of fly ash and fine aggregates for 2 minutes, then mixing the alkaline activator with the water for about 3 minutes. The mixed mortar was then placed in a mold with the dimension of 50 x 50 x 50 mm. Seal the specimen with vinyl to prevent the evaporation of water during high temperature curing process. Cure the specimen in an oven at 60 degrees Celsius for about 24 hours. After that, air drying curing the specimen at an ambient temperature for 24 hours prior to stripping. The fresh properties of geopolymer mortar were investigated by using a mini Conslam test. Test specimens were prepared to determine the compressive strength at curing age of 1, 3, 14, 28, and 91 days in an oven and in air.
Moving on to the discussion based on the findings. In this study, fly ash were activated by using 3 different dosages of sodium hydroxide solution, which is 6, 9, and 12 m. M denotes the alkaline activator, which is generally sodium hydroxide, potassium hydroxide, sodium carbonate, or sodium sulfate to accelerate reaction speed. Next, microstructure analysis was done to evaluate the effect of the molarity and the mix ratio of the alkaline activator on the compressive strengths per H. From the figure, the higher the molar concentration of sodium hydroxide, the higher the compressive strength if fly ash is used as a binder, and the strengths greater than 45 and 46 megapascal developed at 56 days for molar concentration of 9 and 12 m due to the activation of the reaction of the internal alumina and silica caused by the increased breakage of the glassy chain of fly ash. Next is the analysis of the effects of silicon dioxide to sodium oxide and aluminum oxide to sodium oxide ratios on the strength. From the figure, the compressive strength decreased with larger ratios. Strength at 28 days is improved by more than 1.7 times at molarity of 9 compared to 6 m. However, the 9 and 12 m results exhibit virtually similar strengths, which indicates the importance of this ratio in the fly ash-based
Result and
geopolymer.
data analysis. For the slump
In
test,
conclusion, the
first
higher the
specimen
sodium
with 6
hydroxide
mole
molarity,
concentration have
the higher the
185
compressive
mm
strength
of
and
flow.
early strength.
Second
The mix
specimen
of sodium
have
hydroxide and
183
sodium
mm of
silicate
flow,
with a
and
mix
third
ratio of
specimen
1
have
to 1 was shown
180
to
mm of
activate the
flow. For the compressive
geopolymerization of fly
strength,
ash
the
and
strength are
achieve
increasing
compressive
from day
strength
1
of
until
47
day 91.
megapascal,
The
which is
specimen with
known as
12
high
mole
strength concrete,
concentration
and
have the
verifies
highest
the
strength
potential of
compared
fly
to
ash
6 mole
as a
and 9
replacement
mole
for cement.
concentration of sodium
However,
hydroxide.
this geopolymer concrete is more suitable for precast concrete because the compressive strength can be developed at temperatures that exceed 60 degrees Celsius.
That's all from us. Thank you.